In the last video, we talked about ripples, disturbances that travel across the membrane and return it to flat when they pass. But some distortions don't return to flat. Under the right conditions, they get locked in. The membrane folds into a shape from which it can't escape on its own. This isn't because something is holding it there from the outside, but because the geometry of the fold itself prevents the return. Each part of the structure holds every other part in check. The membrane is its own trap. That locked fold is a knot, and that knot is the basic form that matter takes. Think about what happens when you dent a car door. Press on it gently, and it springs back. That is a ripple, but if you hit it hard enough, the metal crinkles. Now it stays. You would have to hit it at least as hard from the other side to pop it back out. The membrane works the same way. Below a certain energy threshold, every disturbance is temporary. Above it, the substrate can reach a new configuration it can't escape from without at least as much energy as it took to create it. Mass is a dent in the membrane. The simplest stable knot that the membrane can form is called a trefoil knot. It has 3 lobes. Each lobe holds the other 2 in place, like 3 interlocking arches. Any attempt to undo one lobe tightens the grip of the other 2. The structure is self-reinforcing because of its own geometry. Why 3 lobes? Because fewer lobes aren't self-reinforcing, they unravel. And more lobes carry more energy than the membrane's tension can settle into. They shed that energy as ripples until they reach the minimum stable configuration. The 3-lobed trefoil is the unique solution that survives. It is the lowest energy stable configuration the membrane can sustain. Every known stable structure in the observable universe is either a trefoil knot or a composite braid of trefoil knots. That is a big claim, but it's grounded in the geometry. If the trefoil is the only stable configuration, then everything made of matter is made of it. You have heard of quarks, the 3 constituents that physicists say are inside every proton. Wave physics doesn't dispute the experimental observations. What it disputes is the interpretation. When high-energy probes scatter off a proton, they find 3 distinct peaks, each carrying roughly 1/3 of the momentum, with no substructure detectable below the measurement limit. In wave physics, those 3 peaks correspond to features of a single trefoil knot, either its 3 lobes or the 3 primary crossing points of its strands. There aren't 3 separate objects inside the proton. There is one object, and it has 3 prominent bumps. Imagine a 3-legged stool turned upside down with a tarp draped over it. You see 3 distinct bumps. Conventional physics calls those bumps quarks and tries to study them as independent units. Wave physics points out there is only one stool. The bumps are just where a single object is stretching the fabric. The electron, however, isn't a knot. It is a ripple, a trapped collimated wave, circling inside the knot's central region, which we call the binding site. It doesn't orbit the nucleus like a planet around a star. It resonates inside a geometric pocket formed by the knot's own topology. Remove the knot and the electron speeds off. This means the proton, the neutron, and the hydrogen atom aren't 3 different things. They are the same trefoil knot in different conditions, empty, occupied, or integrated into a larger structure. Their differences in charge, stability, and behavior all follow from the geometry of that single chassis and what is or isn't sitting inside it. This view of the basic structure of proton, neutron, and hydrogen atom is fundamentally incompatible with the electron probability cloud assumption, which posits a nucleus with electrons orbiting around it. If the wave physics view is correct, every chemistry textbook in every school on Earth will need to be rewritten. How can knots in a membrane move from one place to another? We will discuss that in the next video.